So good morning. So we are in the robot programming. So the continuation of the robot programming, we'll have the next programming language to the AML. That is a manufacturing language. Okay. So this language was developed in 1976 at J.K. Watson Research Labs for assembly-related tasks. So it provides a system environment in which different user robot programming interfaces that may be built over on it. So it supports joint space trajectory planning in order to subject to position and velocity constraints over on it. So we'll have the relative and absolute motions which can be handled and the sensor monitoring which can interrupt motions as necessary. So the most unique capability of AML வந்து பார்த்தோம் அப்படின்னா is its operations and data aggregates. So that என்ன ஆகும் கேட்டா many operations and data rotations and coordinate frames that can be handled as multiple operations in one command. So this capability will make the language more difficult to understand but simplifies programming and controls overall. The next programming language is about Pascal. So Pascal, we all know that it is a standard programming language which is developed by Blaise Pascal for data processing, which uses structured statements in order to organize the program in a modular and efficient way. The structured statements என்ன பண்ணும் அப்படின்னா it will force the program into separate modules in order to reduce the number of branches. So each module is a self-contained and each can be entered only at the top and excited only at the bottom. So that errors வந்து பார்த்தோம் அப்படின்னா due to branching mistakes are easier to catch and eliminate over on it. So whereas the case of an Pascal பார்த்தோம் அப்படின்னா so the data types which are to be the descriptors that identify elements in the language such as integers, real numbers and characters. So it is a well-known and widely used language and it was chosen as the basis for several robot languages. So whereas the case of an PAL வந்து பார்த்தோம் அப்படின்னா so it added capabilities to Pascal to Wave and the AL language. So by providing a new type of language தான் என்ன பேர் அப்படின்னு பார்த்தோம்னா PAL. It is Pascal to Wave and the AL language. So this allowed them to take the advantages of the well-known Pascal language and they can able to provide a new capability. So in the PAL data structures, the relationship between the arm and the object, which can be given explicitly by the use of homogeneous matrix transformations. So every motion statement வந்து பார்த்தோம் அப்படின்னா in PAL வந்து will causes the manipulated position and orientations to be specified in an equations which represents a closed kinematic chain. So an interesting and potential valuable capability of PAL வந்து பார்த்தோம் அப்படின்னா is the ease with which unknown points that can be picked up from a task and it can be incorporated into the program. So we'll have every motion statement which causes the solution of homogeneous equations, which represents the position of the kinematic chain of links and joins in the arm overall. So finally, we'll have a MCL, that is which was developed in 1978 by McDonnell Douglas in conjunction with Cincinnati Millicon for an Air Force ICAM project. So this language is based on APT, the control language for numerically controlled machine tools used in CAM. So one of its advantage பார்த்தோம் அப்படின்னா it's a large number of programmers which already use this APT in CAM applications. So we have a specific constructions to specify points, lines, patterns, and so on, which are useful in enabling robots in order to communicate and cooperate with the machine tools. So the next language is to be the rail language. It was developed by Automatics Inc. for the control of both vision and manipulation. It contains a large subset of Pascal commands and it can handle a variety of data types over on it. We'll have an interpreter which is used to convert the language constructions to machine language commands. So inspections, archiving, and vision operations are supported by language capabilities. So we'll be running on a powerful Motorola status systems. So whereas in the case of an RPL பார்த்தோம் அப்படின்னா, it was designed at SRI, so specifically for unskilled programmers, factory production engineers, line foremen, and so on. So whereas RPL is a low-level language, it has a compiler in order to produce interpretable code from programs and an interpreter for that code. So the language is implemented as subroutine calls so that it is modular and flexible in use. In the case of an RPL, which is used to control a animation Puma 500 ARM and the Machine Intelligence Corporation vision model. So some of the ideas of the Lisp language வந்து பார்த்தோம்னா, which has been organized into a Fortran-like syntax. So it is a language designed for artificial intelligence use. So it is primarily recursive and it is especially well adapted to handling list of informations. As in the case of an ADA, it was developed by ADA Lovelace for the Department of Defense in 1978. So it has been specified by DoD as the sole system implementation language for the programming of real-time embedded system. Whereas the chief advantages of ADA are the powerful data structures provided by the ability to separate control operations from data operations and the inherent capability for concurrent operations of many tasks. So whereas the concurrent operations is an important requirement for the efficient use of multiple robots and other equipment, whereas the ADA is well suited for the control of manufacturers cells using robots. In addition, it is expected to provide code that is easily transferred between computers and it can be easily maintained. The next language, which is known as the VAL, another language is developed by the existing upgrading. It is to be the VAL, which is developed by Vector Scaman for the Innovation Corporation in the year 1975. So it uses simple words to describe the operations which has to be performed by the robot, which leads to real-line programming as given below. So we'll have a specify and transform the coordinates of positioning points both in a Cartesian system and joint language, and it can able to edit robot programs written in VAL. It can manage the execution of other programs. So it provides for seat control, grasping, arm movement, and signaling in a simple, easy to understand framework. Of course, all of these routines are implemented by subroutines done in BASIC and translated by an interpreter. So higher efficiency, which could be obtained by the use of compiled BASIC if necessary, but usually it is sufficient to call pre-compiled subroutines. So the need for a signal to other robots and machines is handled effectively by the use of the interlock commands such as wait, signal, and delay, which take action on the occurrence of specific event. So it is a low-level language and calls therefore for detailed planning of all actions. It provides the executing command suitable for Puma robot for the applications in assembly, arc welding, spray painting, and material handling. So involve both teaching and offline programming, which can be used in an effective way. So this language is modified into VAL2 by adding some more instructions for the operator convenience. So apart from that, we'll have a motion programming. So I have given some examples for the motion programming. So we'll have a move P1, which is move to variable P1, learn P1 அப்படின்னா, we have to record the coordinates. So moves P1 அப்படின்னா, that is we have to go for the straight line motion, and we move அப்படின்னா, we'll be having of an incremental move join code with the help of an 25. The next thing we have to define path. So 1, 2, 3, which case the move path of P1, P2, P3, and we have to move the path. On the initial statements, we should have the speed of 0.5 Mbps, and we'll have executive program, and the speed will be given over on it. So other programming statements in we'll have a interlock and sensor commands. So we'll have a wait command, we'll have a signal command, and we'll have an open command, we'll have a close command, we'll have a computations and programming logic, and we'll have a go to control. So wait until the signal on port is on. Similarly, switch on. Okay. And so switch signal on. So 6.0 which will be representing switch the signal to 6 volts. Then we'll have open and close to the port. So if conditions are we have to go to the next level. Okay. The next instructions, which are to be the welding instructions, we'll have a wset command, wstart command, wend command, and create a fill command. So wset command it will set the speed, welding voltage, and the current. Okay, which will be identified the number 1 to 4. அதே மாதிரி start command which will be welding under present welding conditions and weaving conditions. end which will inactivate the welding start signals. Create and fill instructions Greater filling is required at the welding end of the welding. The example of robot programming பார்த்தோம்னா, so we have to write the programs to above letters by robot in VAL language. அதாவது for example, இப்போ K இருக்கு இல்லையா, K 1, 2, third into the reference 4 and 5. S letter பார்த்தோம் அப்படின்னா 6, 7, 8, 9, 10 and 11. Okay. So இப்போ for example, move save, we'll have a signal X. So signal 6. So next one, move enter, move lock 1, move lock 2, lock 3, lock 4, lock 5. So program continuation, intervene, move save, signal 5, so wait till, signal 6, so we'll go on up to 12 over on it. So this palletizing problem we have to assume that it is desired to pick up identical objects from a known location, and then it has to stack the objects on top of each other to maximum of 6. So the object of the cube 50 mm length. The robot's origin should be assumed at a shoulder joint. So this we have to write a program in PAL. So this is a workspace for VAL programming example. This will have a robot origin with the origin of XY plane, and we'll have a deposit point over there. So program stack will have a remark. So remark this program it has to pick up from a fixed one. Similarly, remark locations called pick up then deposits them at 8. So similarly, it is assumed that 6 parts have to stack on top of one another. The palletizing problems because we have to set B for the deposit, we have to set a consequence 0. Set n of the pickup values. We have to go for most pickup, and we'll have a close in the parts, and we have to move. Okay, so this will be carrying out with the help of shift B by 4 to 20 speeds. So these are the parts. So what are all the advantages of offline programming? It can prepare programs without using the robot, so that the robot is available for other users. Similarly, it is previously worked out to procedures and routines that can be incorporated into the program. And finally, we'll have a layout and cycle time of the operations which can be optimized in advance. So in order to continuation that, we'll have a sensor which is used to interact with the external environment and appropriate actions can be taken in response. Existing computer-aided design and computer-aided manufacturing information which can be incorporated into the control functions through proper interfacing. And the robots which can be used to manufacture individual units by calling on previously developed routine. And also it would be practical to do this by guiding and adapting to match different paths. So the programs can be run in advance to simulate the movements actually programmed without incurring the risk of damage. What are the limitations of programming languages to Partner? Existing robot programming languages will have a limited ability to use subroutines. Some of the early generations controllers will have lots of memory capacity. The languages are difficult to change, learn. Similarly, it changes radically over the time. So this is the biggest problem with the programming languages. Okay. So next method, simulations and offline programming, so that we can see in the next class. Thank you all.